Hey gang, welcome back. You know, I was looking at my schedule for this week and there's nothing too earth-shattering in terms of repair work that would be really fun. So it's all kind of generic stuff. What I thought I would do instead is take you through a day in the life, some snapshots along the way from morning to night so you can see what my workload is like. The other thing is I'm also building a guitar right now. So I'm splitting my time up. And that can make things a little bit chaotic because I'll be, working until like midnight, make a real mess of the shop, clean it all up, try to get enough of space to put a guitar on the bench to repair, and then do the whole thing over again. So I'm kind of working through, it's kind of dichotic. Anyway, the first thing on the bench this morning is a Gibson. This is a Mystic Series Hummingbird, which is a limited edition. It's so new looking, and I thought it was brand new. It even has a hang tag. It's actually used. And what we're going to do is put a LR Baggs Anthem pickup system in there. It's been a while since I've done an Anthem, so this should be fun and interesting. Yeah, it's really clean. Very clean. It's got a very pretty piece of rosewood for the back here. It's heavily figured. It's got what looks like flames, almost like crotch grain or stump wood here. Very nice. I would think long and hard as a builder before putting that kind of wood into a guitar, though. This is not quarter sawn. This is the opposite. This is flat sawn wood. Here's a piece of spruce, piece of top wood. In quarter sawn wood, all the grain lines run parallel to each other and also from 90 degrees from one side of the board to the other. So if I had to split this, break it, see how it breaks pretty much at 90 degrees to the surface. This is oriented in the opposite direction. It's like this. So this is the flat side of the grain lines. But it's also been cut through at an angle when they did the sawing. That's what gives us that strange sort of cathedral grain figure. It's what we call it. It's little arcs. So you've got the grain line running like this through the board. If it ever happens to split, it's going to split like a fish mouth rather than that nice straight pattern, which is more difficult for the person who's trying to fix it. But it's also, if you think about the grain that's running here, between each of these little zone lines, these growth lines, is only maybe like 3/8 of an inch or half an inch long at this point, because the board is only 3 millimeters, 1/8 of an inch thick. So it's not structurally as sound, not nearly as sound as a quarter sawn piece of wood, and it's going to move quite a lot more during the winter. So if you've got a guitar that looks like this and you live in a climate where your furnace is going to come on, you definitely have to humidify it. Keep it in the case. You would not ever hang this on the wall. If you do, your back's going to blow up. Actually, right here, there is a little check forming in the wood under the lacquer. So fun times ahead. It runs along one of those little flames from the crotch figuring. Now, I don't mean to disparage Gibson on this. This is fine. This is beautiful wood, and it just maybe we should have used it in a laminated back rather than a solid back. That's the only thing. It's gorgeous, and it has, a lot of visual appeal. It would make a wonderful guitar in another configuration, that's all. I'm just checking out the bridge plate to make sure there's enough room for the microphone part of the element system, and it seems about right. I don't know what they're using for wood now. That doesn't look like maple. Doesn't look like rosewood either. Don't know what their bridge plates are made of. They've also started laser etching, it seems, all of the sound hole bracing, and these actually say Dove H88, despite the fact that this is a Hummingbird guitar, so I guess they share parts. And there is also a blob of what looks like black Sharpie marker, a scribble just on the inside of the sound hole lip, right about where I'm going to put the pickup. Okay, take that saddle out of there. Comes out easy, and we'll mark the front side so we know which way to put it back. Actually, to be honest, that is a little looser than I would like. We're going to put the piezo element under there. And if it rocks too much, you only get like one side of the saddle contacting it, and you don't get proper energy transfer. So what we'll probably end up doing is like painting a line of super glue on either side of the portion that's underneath the surface of the bridge, and that'll stiffen it up just a little bit. It's really close. It's just I want it a little bit more snug than that. And it seems that Gibson has already drilled a hole for the pickup right in the corner of the saddle slot for me, so that's nice. I don't have to drill it. The other nice thing is there's already a hole drilled for the jack barrel, and it's the right size. There wasn't even an end pin in there, so way to go. Score. Just going to use my little hook tool here. Hook that on the block on the inside. Mark it. It's probably going to be about 3/4 of an inch, maybe 18 millimeters. Yep, 18 millimeters. So I can transfer that to the barrel with the washer and also a little spiked washer there. We'll move that along so that we've got the right length of barrel here. It's my regular 1/4 inch jack, which I've peeled off some of the exterior components so that it fits through the hole nicely. And I can use that to fish the jack on through, making sure I've got the correct washers already in place so we don't leave those off. I'm just going to sand and lightly clean the bridge plate before I try to stick on the element. This is more important than older guitars where you've had some time for the wood to oxidize, but any guitar can be a little bit dirty under there. And we want to make sure that the adhesive has a good chance to stick. So, quick little sanding, a little bit of cleaning with naphtha. Having a light on the inside of the guitar makes threading the piezo element a lot easier. Got to get in there and check with the mirror several times to make sure the placement is just where you want it. There's not a whole lot of room on the front side of this bridge plate. I want it on the front side, but leave enough room for the ball ends of the strings. And centered. Now here's the burning question. Where do we put the battery bag? Ordinarily I'd like to put it right up against the block, but this has a sticker on it, which kind of lends me to believe that it's got a bolt-on neck somehow, and it's kind of lumpy in there, so yeah. It says Gibson Acoustic, let's not ruin the sticker, the originality of the instrument, etc., etc. So we will put this just down here by the waist. There's a couple of braces there, it'll go right between those. I think that'll look okay. Okay, so I took a couple of swipes of super glue on both sides of the saddle, just down in the bottom area here. And obviously let it dry before you put it back in the slot. And that's thickened things up enough now that it's no longer wiggling around in there. It's still easily removable by hand. That's important. You don't want it too tight, but it's not going to lean on the pickup in one side or the other. You'll get better energy transfer, more even response. And because the pickup has raised the saddle height slightly now, I've got to go back, we'll check out the action and adjust it, probably take it down a little bit to make up for the difference in height. Okay, I don't have a great acoustic amp, so basically what I'm doing is just checking to make sure the pickup works and that the setup was successful. Seems that way. There is a little feature on here that lets you regulate the intensity of the two elements of the pickup, the microphone and the piezo strip. That's probably best left to the customer using his own equipment to figure out exactly what he wants. Got a good low action, and sounds pretty good. Not bad. So I think we'll chop this one up, we'll put that back in the case and move on. Okay, so up next we've got this Gretsch 5120. I did some work on this guitar some time ago. We did a pickup swap, removed the stock pickups and put in some nice TV Jones. Also got some locking tuners, new nut. We discussed, the owner and I, at some point replacing the stock bridge with a roller bridge. At that point he just was going to see how he liked this one. He doesn't use the Bigsby all that much, but he thought that he might save up and get a roller bridge at some point. We might be doing that. However, in the interim he's noticed some strange sounds happening when he's playing in sort of, he said, the lower positions. I thought maybe it was a truss rod adjustment necessary, so he dropped it off and we quickly did a quick adjustment and realized, no, that's not exactly what was happening here. So I think we've got another issue. I'll see if I can illustrate. This guitar has sort of medium action. Hear that little bit of a buzz there? Now that's pervasive on sort of the middle of the fretboard on the lower strings. And first I thought, I heard it, in the first position. That would be sort of classic truss rod adjustment territory. I've adjusted it so it's got about 11 thousandths worth of relief in the neck, which is plenty for this style of guitar. And next thought is maybe that's, fret buzz, but no. Went back and forth with the rocker there, and the frets are, pretty close to being level all the way along. The other strange thing is, even with an action that's 4.5 64ths, sound remains pretty much the same all the way up the board. And in any case, every fret where the sound is happening, there is enough clearance over the next fret. Like there is, it's not rattling on the next fret. Which leads me to suspect the bridge. You can see this bridge is set up with the bottom 3 strings, the saddles are reversed, theoretically to give you more intonation capacity if necessary. What can happen is if the groove is too wide, or if it's rough on the bottom, or in this case where you've got a fall away towards the front of the string, if that is rounded or not very distinct, or in any case where you've got a bridge with a long after length for the string and not too much downward pressure, it can start flopping along on top of that flat little groove, and it'll give you a sound that's characteristic of a sitar. That's how you make a sitar sound the way it does. You run the string over a flat little plate. So what I'm going to end up doing is taping off around each saddle. I'll get my nut slotting file, and I will make sure that the break or the takeoff point is towards the front of each of those saddles, and make sure that the bottom of the groove is good and clean. I'll use some fine sandpaper and give it the best opportunity for ringing clear. Now, this gentleman was talking about roller bridge, and that's a good idea, I think. They tend to be a little bit less noisy than the ABR style bridges. Of course, you've got metal strings running over a metal saddle. It's going to be clinky. There are going to be some strange, buzzy harmonic overtones in any case. Usually those don't come through an amp. This was a bit extreme, and he plays at relatively low volumes in his home, so he can hear it and it annoys him. So I think we'll do our best to get that cleaned up for him. But a roller bridge is a pretty good idea, I think, for any Bigsby. But it depends on how much you use it as well. If you're touching your Bigsby once, a show, it might not be necessary for everyone. But I like them. Anyhow, let's do that. Okay, that's much cleaner than it was. I don't think we could ever make it absolutely perfect, but it's as good as this bridge can be. So let's move on. Little sharpening break. I'm going to glue this thin ebony headstock facing directly to my workbench. It's the best way I know of holding it in position rather than trying to find some way to clamp it. Now I'm developing a design for a headstock shape for this 7-string guitar I'm working on. Got to find a way of dealing with the imbalance caused by having the 7 strings and also that tapered fingerboard end. It's going to be sort of a snakehead design here. It's just sort of, I do this all, the old-fashioned way with pen and pencil and paper, sometimes graph paper. I'm not much into CAD. Got some nice hip shot tuners, so I know how far away from the edge of the headstock I want the center of those holes to be, so I'll just mark it along there with a compass. And then I can come up with an elegant design for the holes. I'll just prick those using a set of dividers. And then just sort of give myself some reference. I'm using a circle template to make the washers and the string posts so it'll look sort of the way it does in real life. Then some fancy cutting.
I think that looks okay.
So I'm working on the headstock joint here for this interesting 7-string guitar I'm building for Adam Hendy. I've already got the fingerboard roughed in here with the fret slots cut and it's bound. It's also got a 0 fret. Something interesting about the geometry of a multi-scale fan fret instrument here. If you use a scarf joint that goes across at 90 degrees like we normally do, and set this up so that the nut has a solid support underneath the entire width of the nut, you end up with a little hump on one side that you have to deal with because it doesn't meet the back of the nut in the same plane. You could extend it so that the bass side is running over there and then make a Martin style nut that meets the back of the headstock at the same angle, but you end up again with this weird little gap in between the end of the fingerboard and the surface of the headstock. And you have to find a way of either filling that or dealing with it some way. What I've come up with is I'm just going to angle the scarf joint itself so that it mirrors the end of the fingerboard here. I'll have solid support under the nut the entire width. I've just been planing and scraping this face down so I make sure my geometry is going to work out. The interesting thing that happens, obviously, so in this case the headstock facing is going to come up and it'll all be in the same plane. So here's the rub. I've got this interesting parallelogram thing here. So the way I've done this, I've got the 13-degree angle. It's the same on both sides of the neck, just moved backwards slightly to accommodate the angle. If I go ahead and I glue that directly to a flat scarfed headstock blank like this, and plane it out so that it's flat, I'm going to get a nice plane. But just noticing that one side is thinner than the other, and I imagine when that's done you're going to end up with either a tapered headstock or it's going to be canted in the direction of the treble side slightly, like a degree or two. And I don't know whether that's going to be annoying or not, so I'm just going to have to do some more visualization. In any event, I think the first thing to do is probably to glue on the headstock or the back strap facing that we're going to be using on this onto the headstock part, so I can have like final dimensions. I know exactly where the back end of it's going to be, and I can plane it down to whatever angle I need to make this work. Change of plan. I realized I could cut a mating parallelogram on the other surface that would get rid of that disparity in widths at the short end of the point.
You can see I've glued on a block under the thin portion at the end there so that it's not going to bend and deform under the pressure from the file. So that came together quite nicely. I'm happy with that. It's time to glue on the back strap. One of these days I'm going to get a better camera. It's on the list. And I'm going to use my vacuum bag system here to clamp it. I've got a piece of paper on top to keep the glue off the bag. Clamp it up, and we'll turn on the vacuum. It's nice, especially for a shape like this. It would be very difficult to clamp that tapered section at the end there and get even pressure all along. I like the vacuum. I'm mixing up a batch of epoxy to use with some carbon fiber tow, which is like it's like a bundle of little carbon threads. And I'm using the scale to measure it out here because the proportions are pretty critical for this stuff.
You can see I've got a braced top here. This is Sitka spruce. And for this 7-string we're trying something different. This is standard X-brace with a little bit of a lattice brace component in the lower bout here. And I've gone a little bit light on the lattice. And I'm going to be using carbon fiber here as a reinforcement on top of the lattice to add stiffness. And it's kind of messy, this stuff. Not that easy to work with, but what it'll allow us to do is go a little bit lighter in terms of the thickness of the top, reduce the mass while retaining the stiffness. So I've taken measurements of how heavy the top is unbraced, and just using the carbon fiber here on the lattice section. And we'll figure out what we've got in terms of net gain in weight, and also we can figure out what it does to the tap tones and the stiffness of the top overall. This System 3 epoxy I'm using is quite liquid for about 15 minutes, and then it starts to gel up, and I can kind of comb the fibers into some sense of order. After it's fully cured, tomorrow I can go back and sort of lightly sand the edges and blend the profiles in and make it look a little more presentable. But the main thing is it's going to be very strong, quite stiff. And I think I've had just about enough for one day. I'm going to go have a shower, get cleaned up, and find something else to do. Anyhow, thanks for helping me in the shop today, and I will see you again soon. I think I got a pretty interesting repair coming up this week involving sound ports, so you'll probably see that next time. Take it easy, guys.